Alright, hi guys, we're going to do a quick video on differential equations, aka Diffy Q problems. Basically what these are is anytime you have an equation that has a derivative inside of it somewhere, so here's our derivative, then it's a differential equation. Differential equations are equations with derivatives in it. It kind of just sounds like it said, equations with derivatives in it. So what I usually do is I take the y prime and I change it into dy dx. Means the same thing, but it's going to help us out better. This is our dy dx. We have x squared times dy dx plus y equals 0. What we want to be able to do is we want to be able to solve for y. We want to solve for y, and we want to figure out what was y equal to before this derivative showed up. So before a derivative means we need to anti-derive. We need to go backwards. We're going to use some integrals to kind of figure this out. So the general steps are this. We are going to separate this equation. We're going to separate, and then we're going to integrate. So I'm going to write 2 stars here, separate and integrate. And that's kind of our general steps to solving. You separate and integrate. You separate the variables. You get x's all on one side, y's all on the other side. Currently, what we got going on here is we have this plus y that I'm going to subtract to the other side. I'm going to go x squared dy over dx equals a minus y. Then what I'm going to do is I don't want this dy dx anymore. I don't want it in a fractional form. So I'm actually going to multiply it over to this side. So x squared dy equals negative y dx. No more fractions, which is great, but we didn't separate very good because we have x's and y's, x squared and dy, and negative y dx. So what I'm going to do to fix this is I'm going to divide the x squared underneath this side and divide the negative y underneath this side. I'm going to have dy over negative y equals dx over x squared. And now I've hit that separate step. So I'm done. We've separated. We have all the y's on the left, all the x's on the right. So here's our separate. In the next line underneath this, we now go on to integrating. So I'll scoot this up. So we're going to draw an integral. We're going to integrate dy over negative y, and we're going to integrate dx over x squared and solve both those integrals. Probably going to be easiest if you factor out a negative and rewrite this integral as 1 over y dy equals integral x squared is in the bottom, so I'm going to make it x to the negative 2 power dx. And now it should be pretty easy to do. 1 over y, I've memorized that. That's the natural log absolute value of y. So I have negative natural log absolute value of y equals x to the negative 2 is actually, if I add 1 to the power, it's x to the negative 1 divided by negative 1. And then because both of these integrals did not actually have bounds, they both get a plus c. I have a little plus c here on the left and a little plus c here on the right. The plus c stands for basically some random constant. So what I'm going to do is I'm going to combine these together. We don't really need 2 plus c's. So I'm going to combine them together and make this a little bit easier and say I have negative natural log absolute value of y equals, let's fix this up a little bit, negative 1 over x to the first plus my combined c. Looks a little better like this. Then I'll go through, and I don't want this negative natural log. I want to make it positive. So positive 1 over x. And I could make this a minus c, but it doesn't really matter. I just got this constant here. It's just a random constant. Plus or minus doesn't matter too much. And what I'm going to do next is solve for y. So to get rid of the natural log, I'm going to use e. E to this power of natural log and e to the 1 over x plus c. That's how I'm going to get rid of everything. E and natural log cancel each other. So I have absolute value of y equals e to the 1 over x plus c power. Just like that. So to solve this thing, the next move I'm going to do is I'm going to get rid of the absolute value. We don't really need absolute value because e to the anything Think about the graph of e to the x. Here's e to the x. It's never going to be in the negative down here. It's always in the positive. So we don't need to absolute value anything. So I'm just going to say y equals e to the 1 over x. And instead of writing my little plus c, I'm going to use an exponential property here. I'm going to say times e to the c power. And e to the c power, well, this is just some really big constant. It's 2.718 whatever to a constant power, some c. So all this is one big constant, one big c. So I have y equals this big C times e to the 1 over x power, and that is going to be my final answer to my differential equation. And this is called a general solution. A general solution. So the highlights are you want to separate your variables. Y is on one side, x is on the other. Then you integrate both sides, you get your plus c in there, and then you solve for y. And solving for y, the last few steps is where a lot of the work is. So separate and integrate. So hopefully that helps with Diffy Qs, and maybe there'll be another video posted here soon.